Hey everybody, welcome to NiFi Notes. I'm Mark Payne, and this is the channel to quickly boost your skills with Apache NiFi. Today we're going to take a look at one of the most exciting new features of the upcoming NiFi 2.0 release, the ability to build processors using native Python. So let's jump in. Alright, so here we have a running version of NiFi 2.0 Snapshot, meaning that this is a pre-release of version 2.0. So anything that you see here is subject to change before 2.0 gets released. But I want to demo for you to start what it's like to use these Python-based processors, and then we'll take a look at how we can actually build our own Python processors. So if I drag a processor onto the canvas here, everything looks more or less the same as it did before. But if I search for Excel here, we're going to see this processor that's been around for a while to convert an Excel spreadsheet into CSV. We have this new processor convert CSV to Excel. And so you can see here that the bundle that it's in is actually the Python extensions bundle. So this processor is written entirely in Python. So we'll go ahead and add that to our canvas. And then we'll go ahead and generate some dummy CSV data to feed into this. So I'll use a generate flow file for that. Okay, and then once we've converted that into an Excel spreadsheet, I'll go ahead and route that to a funnel. And we'll go ahead and auto-terminate failures. We know we're not going to have any failures anyway. Okay, so we can go ahead and align these components just to keep everything nice and tidy. And so if we generate some data here, we can view that, see that the output is exactly what we expected, and we'll go ahead and run this processor, and the output has gone now from 45 bytes to 5 kilobytes, which is not surprising that it takes more space to store that data as an Excel spreadsheet. But now if we go ahead and hit download and we open that, well, we'll probably want to rename it first. And we should be able to go ahead and open that as an Excel spreadsheet. And there we go. Now this processor makes use of the Python pandas library in order to do this transformation. And so the really great thing about this new capability is the ability to use all of the huge number of Python libraries that are out there in order to manipulate our data. And the API is pretty simple to use. So let's go ahead and take a look at what it took to write this convert CSV to Excel processor. So it's sitting here in the Python extensions directory here. Make this a little bit bigger. And so as you can see here, we've got our standard Apache NiFi header that takes up probably about half of the contents almost of the entire processor, some standard imports, and our class definition. So here we're extending from flow file transform. And then we actually have a little bit of boilerplate for us here. So first we have an inner class called Java. And because NiFi is a Java platform, we need some way in order for the Python process and the Java process to communicate with each other. So this is basically just this processor saying, from the Java perspective, if you want to interact with this processor, this is what you can. This is how you can interact with it using this flow file transform interface. And so there's a lot more details about this in the documentation, but for now, suffice it to say that we just need to have this simple declaration here. And then we have this processor details class. So here we're specifying the version, a description. So if we drag a processor on here, so converts a CSV file to a Microsoft Excel file, that's this description that's listed here. And some tags here, CSV and Excel. So that shows up here, CSV and Excel. But we also have this dependencies here. And so this is a simple way that this processor is able to declare its third-party Python dependencies. In this case, pandas and XLSX writer. And so these arguments more or less are just passed to a pip install command. So whatever syntax you would typically use in a requirements.txt file can be included here. So this is just a much simpler way to declare that, and allows us to keep all of this packaged up together so that we can very easily share this Python processor. We've got our constructor that's not really going to do anything. It's just going to ignore everything that's passed to it. And then we have our transform method. And this is, of course, where the magic happens. This is the logic for actually transforming our data. And so this this method takes in a context. And so this gives us the ability basically to access processor properties and that sort of thing. I don't believe we're actually using it at all here because there are no properties. It also takes in a flow file. And so from this flow file, we can get the contents of it as a byte array. We're going to use pandas read CSV method to create a data frame. And then we're going to use this pandas Excel writer class. We're going to go ahead and write out our data frame, converting it to Excel. And we're going to close that writer, and then we return a flow file transform result. So the contents of that result are going to be the contents of this bytes.io object, and the relationship that we want to send this flow file to is success. And so it really is that simple to get the content in, use pandas to read it as a CSV, use that data frame that results from that to write out an Excel spreadsheet, and then just to return those contents back to NiFi and tell it that this is a relationship that we want to send the flow file to. Now, if we wanted to, we could also include some flow file attributes in the output here. So let's say, for example, we wanted to actually update the file name. So we could do that by saying attributes equals, and we'll say file name gets flow file dot get attribute file name plus the string XLSX. And so now if we save this, we come back over here to NiFi. We can run data through again. And so now if we take a look at the contents of this queue, we can see that the newly added one actually now has this XLSX extension on it. And it's as simple as that. It allows us to really quickly update our processor and iterate in order to make sure that it's doing exactly what we need. Okay, so now we've looked at how we can manipulate the contents of a flow file with Python, but we don't always want to load the contents of a whole flow file into memory. So what if we're working with record-oriented data like JSON or CSV or Avro and whatnot? We can also build record-oriented processors in Python very easily. So let's go ahead and make a copy of this same generate flow file processor. We'll use the same CSV that we already had, but now let's add in a different processor. Use one called set record field. This is also built in Python, so we'll go ahead and connect our success to there. We'll send our success there. And if we configure this processor now, we can go ahead and terminate our failure. We have two different properties, a record reader and a record writer. And so we know that our data is coming in CSV. And to write it out, let's go ahead and write it out using Avro. I already have these controller services created, so those are nice and handy. So the data is going to come in as CSV. We want to do some sort of transformation to it, and we're going to write the results out in Avro. This processor allows us then to add user-defined properties, and it's going to set key value pairs in every record based on those properties that we add. So let's add a new property and we'll call it temperature. We'll set a value to on fire. And so if we run some data through here really quickly, we should have the CSV coming in and Avro going out. And so let's take a look at the contents here. And we can see that this is in fact Avro. We can see the embedded schema here. And if we change the formatting to formatted, there we go. We see our original content, and we see the temperature now is set to on fire. And the content type here is application Avro binary, but NiFi gives us the ability to view Avro data using the formatter so that it looks just like JSON. So let's take a look then at what it takes to actually build a processor like this. Being able to use any sort of incoming data we want, format it as whatever type of output data we want, and do that record update all in line here. Alright, so again we have our standard Apache NiFi license header. We have a few imports. Our class this time extends from record transform instead of flow file transform. And again, that's listed there. In this case, we have no third-party dependencies, but we do have this new method called getDynamicPropertyDescriptor. And so this method basically just says that the user is able to add those user-defined properties of key value pairs. So for example, the temperature property that I added. This method right here gives us the ability to allow those properties and optionally specify a validator to use. So we could, for instance, say that the property value must be an integer or whatever makes sense. But if we take a look at the transform logic here, it's again really quite simple. So in this case though, instead of getting a context and a flow file, we get a context, a record to operate on, the schema for the record, and an attribute map that gives us access to all of the flow file attributes. So what we're going to do here is just to get all of the properties from this context, and we're going to look at the keys of those properties. Now, if the key is not dynamic, then we're going to ignore it. So dynamic, meaning that it's a user-defined property, such as temperature. We're not going to worry about the record reader and record writer properties. And at that point, once we've ignored the non-dynamic properties, all we're going to do is we're going to use context.getProperty to get the value of the property, and then we're going to use this method called evaluate attribute expressions. So this basically says, go ahead and run expression language over the value of this property using the flow file attributes. And once we've done that, we're going to put the result into our record using whatever key was provided to us. And then the result, we're going to return this record object, and we're going to say that it needs to go to success. So to illustrate exactly what this method is doing here, the evaluate attribute expressions, we could actually come over here and we might say, okay, we want to add in a file name field also, and we want to use the file name attribute and convert it to uppercase. And so if we take a look at the results, we should now have that newly added field. And sure enough, we do. That file name is in uppercase. And so with just that one method call, it allows us to implement all of the NiFi expression language. So it's a pretty powerful concept there. And that's really all there is to it. Now notice we didn't have to tell NiFi in our processor anything about the record reader or the record writer. All we did was simply indicated that we wanted to extend from record transform, and NiFi took care of adding the record reader and the writer for us. But also notice that the record that we are operating on is actually just a Python dictionary. So this API makes it really simple to interact with these records by just transforming them into a Python dictionary for you on the fly. So even though it's coming in as CSV and it's getting written out as Avro, from the perspective of the person writing the processor, it's really quite simple. So we could easily just say, record test equals hello, save changes here. Now it's not going to reload any changes to our processor while it's running. The processor has to be stopped and started again before those changes are going to be picked up. But we should now see that we did in fact pick up that change to insert hello into that test record just by simply updating that Python dictionary. Okay, so now this is stupid simple and it's crazy powerful, but let's take a look at how we can make better use of some of these Python libraries, because that's really where the power comes in. And so, of course, it's going to be important that we have dependency isolation, because we have no idea what some other processor might be bringing in. So the framework is going to handle creating a Python virtual environment for us for each processor type. So we don't have to worry about dependency conflicts between our processors. So this lets us do some really cool things. We could, for example, run AI models against our data as it streams through the system. So let's take a look at what that might look like. So if I use a detect object in image processor here, we'll connect that up as well. Any failures will terminate. And so this processor needs 3 different files. It needs our model weighting file, it needs our network configuration file, and it needs our class names file. So this particular processor, we're actually using OpenCV. And so for the model file, I'm going to use resources YOLOv3.weights. For the config file, I'll use our resources YOLOv3.cfg. And for the class name file, I'm going to use Cocoa classes that Microsoft provided. And we'll apply those changes. Now, of course, we can't feed in CSV to that. So let's go ahead and add a get file processor to bring in some images off of disk. And I'll configure this. So I'm going to look in the data images directory, and I do want to keep source files. Oops. And so if I go ahead and run this processor, see that 1 file came in, and that if we then run our detect object in image, we get the output here. So let's take a look at what's in there. And so this used OpenCV against our image to detect that there's a dog, a bicycle, and a truck with pretty high confidence. And so if we wanted to look at what that image was, so it was dog.jpg. So if we open data images dog.jpg, we have this image that we all know and love, that we see all over the place when we start talking about object detection. But we have our bounding box here, the X, Y coordinates, and the width and the height. And so what we're seeing here is not that being able to detect objects and images necessarily is going to be an earth-shattering capability for you, but it gives us the ability to do some really powerful things using Python, using all the different libraries that are available there. So you could certainly imagine using NiFi to gather data from many different sources and feeding that data into a data lake. And then once you've got that data, building a model, you could then use NiFi to actually run that model to make inferences against your data as it streams through. I think the options here are really pretty much endless. So this is going to allow you to really build all sorts of powerful new capabilities as NiFi processors. And if you're interested in learning more about that API, you can check out the Python developer guide. So in this build, if we come over here to help, go ahead and pop this out. And over here, under developer, there's a Python developer guide. And so it gives you a quick introduction. It's going to talk about how the Java and Python sides communicate, just so that you're aware of how that works, a common error that you might see, what to do about that. And then we're going to basically walk through the Python API and explain how all these different things work. And so obviously these simple processors will really help out a lot in understanding the API as well. Now if you're interested in giving this a shot, I'm going to upload the build that I use for this video, and I'm going to put a link to it in the comments. Just unzip it, set the Python command to use in NiFi.properties. It does need to be Python 3.9 or newer, and then start up NiFi. I'm going to upload some simple processors for you to use as well. But please note, this is not an official release of Apache NiFi. This is just some dude creating a build of NiFi from where it is now and uploading it so that you can start playing around with it. And one more note of caution. This is still very much in development, so the API may change before the 2.0 release. It's not quite ready for prime time yet, so I wouldn't recommend using this in production, but we're getting there. And please leave a note in the comments letting me know what you're planning on building out with this. I can't wait to hear.